who knows in the world. And put this under triangles, and you're going to want, you will want a new, don't put it under really any other, make it a whole page, because it's going to be, it is a special thing here, because it's actually special right triangles. And the two special right triangles, we're only going to talk about two very, very special right triangles. They are right triangles that have 45-degree other angles. And the other one is a right triangle that has what we call 30 and 60-degree angles. Okay? And that's, we actually call this a 30, 60, 90 triangle. And this one here, I don't know if we call it a 45-degree triangle, I don't remember that from back in the day or whatever it is. Okay. I guess we could call it 45-degree, 90-degree triangle. 45, 45, 90, I don't know. But you might be able to figure this one, what makes this one special on its own, just by thinking about it. First of all, what type of triangle is this? Anybody know? It doesn't look like it there, but if you're categorizing this triangle in our names for triangles, or classifying it, this triangle is Elijah, it is an isosceles triangle. An isosceles triangle. Which means what? Isosceles triangles have two equal sides, and those two equal sides would be those two sides there. Okay? Two equal sides. And when you think about this triangle, we are thinking about the relationships each side have with the other side. Well, we already know that this side and this side are the same. So just for fun and grins, I'm going to make this side 1, let's just call it 1 inch, and I'll make this side over here 1 inch. If I know that both of those are 1 inch, how long is my hypotenuse going to be? Well, there is no triple that's 1 and 1, so you're going to have to sit down and do the formula, which isn't very difficult. The Pythagorean theorem is what? A squared plus b squared equals c squared. 1 squared plus 1 squared equals c squared. 1 squared is 1 and 1 squared is 1. What is, if 2 equals c squared, what does c equal? We're going back to this back in the day. Oh boy, it's been so long. Brianna, thank you. Exactly. Yeah. If 2 equals c squared, then c equals the square root of 2. Which we may or may not know is close to what, 1 point something, 1.2, whatever, there is a whatever thing. So here is the thought process then, people. Here is the crux of a 45-90 triangle. This, I'm going to redraw this triangle here. This little triangle right here that we figured was 1, 1, and the square root of 2, this is what we like to call our base triangle. Okay? Or you might want to call it your reference triangle. Because from this point forward, anytime you find a 90, 45-degree triangle, you don't have to really do any work to find its side, because if you know one of the sides, you can figure out all 3 of the sides. But you're going to say, gee, Mr. Hahn, how is that? Well, let me show you. Okay, so there's my base triangle. I'm going to draw you one here. Take a look, see at this. Let's say you've got a 45. Make it a little smaller so you can see it. Let's say you've got a 90, 45, 45 triangle, and you know that this side is 3. If you know one side, you know them all. Why? Because in a 45-90 triangle, one leg, what's the other leg going to be? 3. And guess what the hypotenuse is going to be? If when these were 1s, this was just 1 square root of 2. If these are both 3s, this is going to be, Elijah? Nope. If when these were 1, this was 1 square root of 2. You just don't write the 1 there. If these are both 3s, this one's going to be, let me emphasize this again for you. If when these is 1, this is 1 in front of the square root of 2. If these are both 3s, this side is going to be 3 square roots of 2. Notice 3, 3, 3, 1, 1, 1. If my 90, 45 triangle, and these are both 8s, the hypotenuse is going to be 8 square root of 2. 8, or we usually say 8 times the square root of 2 just because I say 8 squared is 2. So it makes you think. One more and then I'm really going to get complicated at it. So here's my last one. Here's my 90, 45, 45. If this side is 5, how long is this side? 5. And then how long is this side? Now, you know you have arrived if you can figure this one out. By the way, here, I'll draw my triangle upside down first of all to try to confuse you. And I will tell you that this side here is 9 square roots of 2, or 9 times the square root of 2. What are the other 2 sides? What are the other 2 sides? Kate?
9 and 9.
And 9 and 9. See how tough that is? Okay. This only applies with a 90, 45, 45 degree triangle. That is this special case. And again, hopefully, and here I'll show you here. Let's do this again. But that wasn't what I wanted. I don't even know what that does. Get rid of it. I want this. I'm going to go to the calculator. We're going to take the square root of 2, so you know what the square root is. Square root of 2 is 1.14. Get rid of this. The square root of 2 is approximately, that's that little squiggly equal sign, 1.414. Okay, because you should not throw out there 5 times the square root of 2 without having some inkling about what is. You know, if I was going to give you 8 times the square root of $2, you have absolutely no idea how much money that is. You should have some idea how much money that is. It would be, what, 8? Oh, there, how about that? Okay, it would be 8 times whatever 1.414 is. Well, 8 times, what's 8 times 1.4? Come on, mathematical people. Wow. Well, let's just say it's about 11.2. 8 square roots of 2 is about 11.2 if you're kind of rounding it off, or 11 if you like, which makes sense because it has to be longer than those 2 sides. Got that? Perfect, good. So, that leads you to ask, well, that's one special case. The other one we're looking at is a 30, 60, 90 triangle. And to figure this one out, to figure out what makes this special, I am actually going to do this. What makes a 30, 60, 90 triangle special is that it is half of a 60, 60, 60 triangle. Look, if I split this down the middle, look what happens. Here's my 90-degree angle, and splitting 60 in half, because it has to be, because this is 60 degrees, this has to be 30 degrees. Got that? We get our 30, 60, 90 by splitting 60, 60, 60 triangle. Now, what do you know about a 60, 60, 60? What type of triangle, if I'm classifying this, what type of triangle is 60, 60, 60? Keith? It starts off being an equilateral triangle. And what do you know about equilateral triangles? You know, Keith, that this side equals this side equals this side. Okay? If I know that, let's just for fun, I'm not going to use 1, I'm going to use 2. If on my equilateral triangle this side is 2, what is this side? What is this side? 2. So I'm going to put my 2 up here, because I know this side I'm going to make my 2. But this side over here is not 2. It's split right down the middle. So what is the distance from here to here? I know that's hard. Split down the middle 2, you get 1. Which is what this is. Here's my 1, 2. And then I need to figure out this last piece right here, which is this piece right here. Again, I try to use the Pythagorean theorem. Is there a 1 something square root of 2 or 2 thing over here? No, there's no 1s, there's no 2s, there's no 1. So we're going to have to do the Pythagorean theorem again, because it doesn't work out nicely. A squared plus b squared equals c squared. A squared, let's make this a squared, 1 squared. We don't know what b is, because that's my other leg, but I do know that c is 2, right? Yes, certainly you do. Doing the math, I get this. How do I solve this? Anybody? How do I get the letter b by itself? Anybody? Going once, going twice. Lady Fire? No, subtract 1. Because this is adding 1. So I subtract 1, you're right, it's 3. Now here the question of the day. If b squared equals 3, Cameron Colquitt, if b squared equals 3, what does b equal? Now if you have a question on that, Cameron, I'm going to go back to here where we said if c squared equals 2, c equal the square root of 2. Well, if b squared equals 3, b equals the... Very good. See how easy math is when you just start looking for the patterns? So I know that this is the square root of 3, and I know this is the square root of 3. To which you're going to say, wow, that is certainly amazing. So what you need to pull away from this after I showed you all this, which really wasn't beneficial to you except for you to figure out how they got this. This is what you want. This is your reference triangle. Your 30-60 reference triangle. I'll redraw it over here. Your 30-60-90 reference triangle looks like this. The hypotenuse is 2, one leg is 1, and the second leg is the square root of 3. How does that help you, children? How does that help you? Well, anytime from here on that you see a 30, 60, 90 triangle, you should think of this reference triangle. Because take a gander. If I have my 30, 60, 90 triangle, and I know any one side, because of this, you can figure out the other sides. For example, if this side is 4, what's the relationship between 2 and 1? 1 is half of 2, correct? So this leg is always half of the hypotenuse. So you know automatically this is 2. And what's the relationship between this 1 and this 1 times the square root of 3 that I have there? Well, if this is 1, then that ends up being 1 times the square root of 3. If this is 2, then that side ends up being 2 square roots of 3. So the beauty is, if you know the reference triangle part, you don't have to do any calculating. It's all kind of right there. Okay? Now let's check it. Let's see if you actually, let's see if you catch on to this. Can I do some more? Sure. I'm going to flip my triangle on end and make it look like this. This is my 30, 60, 90 triangle. And what if I said that this was 8 times the square root of 3? If that's 8 times the square root of 3, what will both of these sides be? Once again, going back to my reference here, if I knew this was 1 times the square root of 3, that side ended up being 1, and that side ended up being 2, based on that, Kate, I know that, which one are you going to tell me? The hypotenuse or the other leg?
The other leg.
The other leg is?
8.
8, absolutely. Because whatever number is in front of the square root of 3 is the number that the other leg is, and then how long then is the hypotenuse? Maddie? 16. Notice how you didn't have to do any math at all there, it was all right there. And the same thing, you shouldn't just blindly throw out there what the square root, that you've thrown out square root of 3, you should have some idea what the square root of 3 is, and if we go and do our little calculator, square root of 3, what is the square root of 3 close to? 3 square root is 1.73 approximately. The square root of 3 is about 1.73. So if you really wanted to know what this was, you take 8 times 1.73, and that's close to what mathematical geniuses. It's a little more than 13. 13 plus, which makes sense. Someday you'll want to do that. Now, let's see what the book asks you with this whole goofy sort of thing. Look, open your book so you can follow along with me here. Oh, look, if they do ask you the approximations for the square root and the square root of 3. Look at page 449, example letter D. How many units is it from the origin to 2, 2 on the coordinate plane? How far from origin to 2, 2 on the coordinate plane? So obviously you're going to do this. Where's the origin? Somebody help me out. Origin is where? Brianna. Yeah, 0, 0. And I am finding the point 2, 2, which is here's 1, here's 2, here's 1, here's 2, 2, 2, and I want to know how long this is from here to here. Somebody give me the thought process here. Oh no, tell me you don't. Don't, Aubrey, don't look at me like you have no idea. Look, we just got done talking about making triangles. If I make this a right triangle, what do you know about these two sides? How long is this side?
2.
How long is this side?
2.
If you know they're both 2, what type of triangle does that make it? An isosceles triangle, which makes it what type of special right triangle? A 45, 45, 90. And once you know that the 2 legs are 2, you automatically know what the hypotenuse is, which is, somebody? 2 square roots of 2. There you go. Answer solved, just like that. Everybody's happy? Except for Aubrey. And then look at letter F, because we're here and everybody seems to be very excited about this. A regular hexagon has sides 2 feet long. What is the exact area of the hexagon? What is the approximate area of the hexagon? Oh, you kidding me? 7th graders to be able to do this? First of all, what type of figure is it? It's a, no, it's not just a hexagon, it's a regular hexagon, which means it's what? All sides are equal. So we got our 6-sided shape, and they are all equal. You know that. And we know that the side is what? I gotta make sure I know this. Each side is 2. And what's my question? What is the exact area of that? Well, how in the world am I going to find the area of that? Some suggestions? Again, since we were just talking about special triangles, what do you think we should probably do? What would be the easiest way to make a triangle? How about this? Which some of you might go and say, I don't know what the deal is with that. Now here's where it takes a little thinking. Somebody tell me what they think. And this is a little bit what geometry is like. If you're afraid of this, if you kind of like the stuff you like geometry, if you don't particularly like it. First of all, can we figure out anything about any angles? Anybody know anything about any angles? Let me start you off with here. It's a regular hexagon. How many degrees are in a circle? So if I cut my circle into 6, because these are 6 equal triangles, because this was a regular hexagon, how many degrees is each one of those? So each one of these little bitty triangles has a 60-degree thing here, right? I also know that these are equal, correct? Because they all start from the middle point and go to the outside. And if I know those are equal, how many degrees does each one of these have to be? Knowing that a triangle has 180 degrees in it, and so that means this triangle here has to be filled up with 180 degrees, knowing that these are equal, which makes their opposite sides equal, each angle there has to be laid apart 60 degrees, which makes this a very, very special triangle, right? Because if I cut those in half, I get a 30, 60, 90 triangle. And I know that half of that is 1. How am I going to find the area of all that? Well, there's a couple different ways. How long is this side from here to here? Knowing what you know about 30, 60, 90 triangles, if the short leg is 1, what was the other long leg? Daddy long legs? Do I have to go back for the reference for you? Look. If the short leg was 1, the long leg is square root of 3. So now we know everything we need to know. This is the square root of 3. How do I find the area of a triangle? 1/2 base times height. What is the base? What's the height? 1/2 of 2 times the square root of 3. Anybody tell me what 1/2 of 2 times the square root of 3 is? Oh boy. Failure. Culprit? 1/2 times 2 times the square root of 3 is 2. How does one come up with that? How about this? Let's go slowly. What's 1/2 of 2?
1.
Half of 2 is 1, and what's 1 times the square root of 3? So every triangle there, every triangle is the same, and they're all the square root of 3. If you have 6 triangles and they all are the square root of 3, what is my total area of that? If you have 6 triangles and they're all the square root of 3, what is my area there? If you have 6 triangles and every one of them is the square root of 3, what is my area there? Identity? 6 square roots of 3. Now that was what letter A said, I think. That was the exact area. What would you say the approximate area is? Well, to find the approximate area, you would, instead of the square root of 3, it's actually 6 times 1.71. Is that what you said it was? 73. If you multiply 6 times 1.73, Elijah? 10.38. If you could, could you read me the answer right there in red? What does that say?
6.
No, the next one.
10.38 squared.
See, there you go, look at it. People are pretty happy about that. For tomorrow.